Hi, my name is Mr. Warnow, and today we're going to start talking about limits. Now, what is a limit, you ask? Well, we're going to spend a lot of time on those, but in a nutshell, a limit is a mathematical tool that allows us to think about, well, what is happening to a function at a certain point? For example, let me just take a look over here at the board. Let's say we have some function, some graph, some y, there's our x-axis, and we have some graph right here, but we have a hole, and there's f of x. It goes on forever and ever and ever. So let's say we have this graph right here, and what we're trying to find out is, well, what's happening at this value, at c? Well, we know the value at c does not exist, so we just say d and e. We just know it doesn't exist because there is a hole. There lies a hole there. But what a limit says is, well, what's happening around that hole? What is happening to the function as we get closer to the hole? What are we approaching? And that is why limits are so important for us, because they allow us to solve problems that don't necessarily have answers. So in this case right here, we could say, well, as the function gets closer to x equals c, we're approaching the value f of c. Now, we're not saying the value at c exists. We're not saying f of c exists. We already know it does not exist. What we're saying is we're getting closer to that. And we're going to talk a lot about that today and over the next couple of weeks. So I hope you enjoy this lesson, because for those of you guys taking calculus, this is one of the biggest topics for us. So let's go ahead and learn about limits. Here we go. All right. The question for today. What is the limit of a function? So to better understand a limit and its applications for us in mathematics, we are going to take a look at this graph over here on to the right. Now, if you notice, it's parabolic, so we want to find out what is the value of the function at 0. Well, that's easy. That's just from pre-cal. So if I wanted to find f of 0, I can just go look at the graph. At 0, it looks like the value is 4. But the next question says, what is happening to the values of the function as, don't ever correct my spelling right there, as x approaches 0. That's a big difference, not at. We want to say as we get closer to 0. So in other words, what's happening to the function's values? Well, the function's values, let's say if I start here, start at negative 10. As I get closer and closer to 0, here's x equals 0. That's the line, x equals 0 right there, the y-axis. On both sides, they're both approaching 4. So we would say, as x approaches 0, the values approach 4. Now, this is a notation that you probably saw in pre-cal or algebra 2. And your teachers normally use that to describe something like end behavior of a function. Now, that is not the notation we're going to use in calculus, but we kind of get the idea right there. So as x approaches 0, the function's values approach 4. Now notice they are the same. These are two different questions. In the first question, we are only looking at the value at 0. That's this right here, f of 0. We're only looking at the value at 0. Oh, gotta get a new pen someday. All right. The second question is not asking the value, but rather what the value of the function is approaching as x gets really close to 0. I'm talking uncomfortably close. Like imagine some person asking you out, they don't really care much, they just get closer and closer to you. Would you like to go out? Would you like to go out? Would you like to go out? And they get closer and closer. Go away. Okay? So we want to find out what's happening to the function as x gets really close to 0. In this case, we call this the limit. The limit helps us to understand the behavior of a function as an input approach a certain number. It's to understand the behavior of a function as inputs approach a certain value right there. For example, if I take a look at a little tiny little graph like kind of what we did up on the board there, if here's C, and I have something looking like this, we want to know what's happening as x gets closer to c from both sides. We'll talk about that later on. What's happening to the value of the function? What is that value approaching? And that's what we want to find. As, again, x approaches 0, the question is, what does the value of the function approach? Sometimes it's a number. Whoops, can't spell approach today. And that's what we're looking to find here. So today we're going to start learning about these limits. Again, where the value of a function determines the exact location of a point on a function, the limit of a function asks what the value is approaching as we get closer to x. It's another way to look at it. A real-world example for us, we can think of the value of a function as the house in the picture. So if we look at the house as the value right there, we can think of the limit as the road leading to the house. So we think of the limit as the road leading to the house. Now, in other words, what that means is we want to approach this value. But where do we approach it from? The road, the limit. So we are approaching, on the road, we will approach that house. So in mathematics, just like this, if we think of the value as the point, we can really think of the limit as the function itself. Just a quick way to look at it, okay? Not exactly always necessarily the case, but it's a quick way to kind of think of what the limit is. Better way to put it is that we are on the function itself. So again, let's redefine what we're talking about here. We have the value of a function, and what I like to tell my students is the value of the function is what the function equals. At x equals c. And again, we call that f of x. Or in this case, f of c, because we're looking at a specific x value. The limit, this is what the function's values are approaching. As x gets close to c. And we have a special way of writing this. And we're going to talk more about this later on. We actually write it this way. You might have seen this in a book. The limit as x approaches c of the function. We're going to talk about this in just a few moments, okay? That's how we write a limit. So let's take a look at a couple more, maybe another example here real quick. Okay? So take a minute, pause the video, and see if you can try this one. Okay, I'm going to go ahead and go through it, but you want to pause the video right now if you want to try it. The first question is, what is the value of the function at x equals 0? Now take a look here. At x equals 0 in this case, there's a hole. But down here, there's a point. So we could say that the value at this point right here is at -2. So we can say f of 0 is -2. But the next question says, what is happening to the values of the function? Again, it should be as, boy, it's copy-paste error right there, huh? As x approaches 0. Now this time we are actually on the function itself, close to 0. Okay? So we want to pick values close to 0. And if you notice right here, as I start here, as I approach x equals 0, from the left side, we are approaching a y value that is not the same as the value itself. We're approaching, looks like y equals 4. Even from the right side, we're approaching the same value, 4. So even though we have a value of -2, the limit itself is 4. We are approaching 4 right here. We approach 4. So we can say as x approaches 0, the function approaches 4. Now, notice, this is a big one, that the value and the limit both do not have to be the same. They don't have to be the same. You don't have to approach the same point. Case in point, like imagine like you and your friend want to meet up at, I don't know, a boba tea house or something like that. But you don't tell which boba tea house, right? You drive to a different boba tea. A better example, like when I was in high school, I was invited to a party once. And what happened was they told me the address. And I was approaching the party, but they did a trick on me and the party was at a different place. So I was approaching another house, but the party was at another house. But that's my issues, not yours, so not your concern. So let's see here. And that's a big thing. Now, if they are the same, that's what we want. That we call the function continuous at that x value. If the limit and the value are the same, we call that continuity. And we're going to talk about that quite a bit in this class. So, how do we write a limit? Let's take a look here. The limit of a function, we talked about this already, is written as the limit is written as this notation right here. The limit as x approaches a of a function. It is read as the limit as x approaches a of f of x. In other words, as we approach x, what is happening to the value of a function? Okay, now I am going to go ahead and pause here for now. Please go to video number 2 and we'll finish up today's notes. We'll talk a little bit more about limits.